let me just state he was not younger than me. Just take those fantasies out of your head right away. Thank you. I think I just made it worse. Anyway, thank you for coming. I don't know how many of you are teachers. Right, thank you very much for coming, now that there's so few actual teachers. Just a few words about myself. I put speakers on stage, so I'm in the program committee for various conferences. And as such, when there's a cancellation, as there was for Melbourne, I go on stage, so that's why I'm on stage. Normally I don't put myself on stage, but somebody had to be there. Also, I mess with the heads of students. I've been teaching in computer science at university since '98, also been teaching in the industry. Now I teach teachers how to teach computer science, which is why my company is called Meta Developer. And also I facilitate retrospectives, and I try to make developers talk to each other in various ways. But why would you listen? Why would you come to a presentation about learning if you're not a teacher? Well, I could think of 3 reasons. One of them is that you want to become an expert. And some of you probably know about Dreyfus's skill acquisition graph. How many of you know this already? How to become an expert? So you start out by being a novice. You know the context-free rules. You can follow the rule A leads to B, B leads to C, and thus A leads to C. You can follow those rules. But then maybe you're watching presentations at conferences like this, and you become what you call a beginner. Now you can apply the guidelines. You hear the guidelines. Right, so maybe sometimes A doesn't lead to C because blah, blah, blah. So you become a beginner. And then you start applying your knowledge, and you can become competent. So now you can respond to the unexpected. So instead of just following the rules and the guidelines, you can start to just respond more easily. Then you're discussing your experiences, maybe even giving talks at conferences, and what happens then? You become proficient. Now, in an unconscious way, you can now combine the rules and the guidelines to create something new, and you're competent. But the unconscious competence is important here, because only when you actually start teaching it, you become an expert, where you have a conscious grasp of what's actually going on. Because when you're a teacher, when you have to teach somebody something, or you have to explain something, you have to really deeply understand why it is. Because otherwise you can't come up with extra examples. You can't come up with other explanations. And actually, the first company I worked for, Trifork, whenever you wanted to take a course to become better at something, they'd say, great, we'll sell that course, and then you'll teach it. So that was the way that we could learn new technology at that firm, was to just teach the course. And when you know that you're teaching the course in 3 months, you will be learning how to use that technology. So being a teacher makes you an expert. So that's one of the reasons why you'd want to hear this presentation. Another one is that you want to become better at learning yourself. You want to understand what takes place in your brain when you're learning, what's actually happening, and what can make you better in learning, because you want to improve all the time. As engineer and developer, you want to become better every day, every year. So you need to know how your brain actually works when you're learning. And for that, I've taken a lot of fairly old research. I know that, but I like it, and I still use it, and that's why I've taken things away with me from the 50s and the 70s. I'm going to talk about how to chunk information. I'm going to talk about the patterns and automata in the head. I'm going to talk about learning preferences and constructivism. So these are the things I'm going to tell you about that can help you understand how your brain works when they're learning. And the third reason for you to come to this talk is to have some anecdotes to entertain at dinner parties with. I know you all like that. It's even better than tweeting them, right? So, but let's jump right to that. So this is a chessboard. This is a mid-play chessboard. It's actually when Deep Blue won over Kasparov. It's a 22nd out of the 37 steps that make Deep Blue win over Kasparov. You remember Deep Blue and Kasparov, right? Right, good. So you are awake. And there was a study going on in '73 by Chase and Simon. They wanted to figure out what is it that makes a master chess player in comparison with a novice chess player. What is actually the difference? There had been some research going on already where they looked at the eye movements of the experts and the eye movements of the novices to see what are they actually looking at the boards, what's going on. So what they did was that in this particular study, They took a mid-play chessboard. It wasn't this one. They took a mid-play chessboard, and they showed it to the expert for 5 seconds, and then they hit it. And the expert should put the pieces on his own board. And then he had 5 more seconds, and then he could reassemble the pieces to make it look better, and 5 more seconds, and so on, until he could actually duplicate the pieces on the board. They did the same with the novice. The novice had 5 seconds to look at the board and should put his pieces on the board as well, and then another 5 seconds, and so on and so forth. Now, I want you to think about who do you think did best? Who do you think found this more easily? Who was the fastest in putting the boards on his own board, following the mid-play chessboard? So how many of you think that the expert was the best? How many of you thought that they were equally good? How many of you thought that the novice was the best? Let's look at the result. As you can see, the master chess player was significantly better than the novice chess player in putting the pieces on the board. That was not supposed to be the surprising part. But it is the other side of the world here, so let's move to the surprising part of this research, right? And let's see what's happening. This is not a mid-play chessboard. This is just a chessboard where you use the JavaScript math.random to put the pieces on the board. A child could have put it on the board. Not a Danish child, they're too smart. But some child could have put the pieces on the board. Now it's just a math.random. And now what's happening? How many of you think that the expert is still significantly better than the novice? How many of you think they're equally good? How many of you think the novice is significantly better? How many of you seen this study? Yeah, right. So now you can see that the master is really sweating. The novice is doing exactly as good as in the mid-play chessboard, but the master is really struggling. The novice is significantly better than the master all the way around. And why is that? Because we know that what differs for an expert chess player and a novice chess player, based on this research and other research, is that the expert knows about 100,000 of board configurations and the associated moves, and the novice knows very few of the board configurations. Like the Russian chess players were trained with looking at board configurations all the time, more and more board configurations. That was the way they were trained. So it's not surprising that the experts are better and know more of these. But why was the expert so bad at the random chess game? Anybody who's got any proposals? Yes? Sorry? No patterns. But even if there were no patterns, why didn't the expert just do as poorly as the novice? Because it didn't make sense. Yeah. Because the expert was trying desperately to make sense of the patterns that weren't there. So there was some cognitive overload for the expert here. I've got an anecdote about this, but first, I want to imagine that if this about learning should be interesting for you, maybe in your company you take in a new apprentice, and you want to turn that apprentice into an expert in the system that you're working on. So that will be the case study that will take us through this talk, that you are getting an apprentice, and you'll be the mentor for that apprentice, and what will you do? So now just to something completely different. There's an activity here. Later you'll need to write down some stuff. You probably have phones or paper, some of you. But the activity is that I want to divide you into 2 different groups. So the people on your left, which is my right here, whenever you see a word, you count the letters in the word, and you say the number of letters in your own head aloud, right? And the people over here on your right, my left, when you see a word, you say a related word, like umbrella, rain, something like that. hunger, dessert, things like that. Okay? You got it? Right. So I'll just go through them. You say it in your head. Yes. I know it's difficult. Right? Right, thank you. I won't talk more about that until later. Let's go back to our apprentice example. So you want to teach this apprentice, so you talk all day and you use a lot of examples and you try to push all the knowledge that you have in your head into the apprentice's head. Because the faster you can do that, the faster the apprentice becomes an expert and you can start working on your own thing that gives you KPIs or whatever you want to have. But why does it not work? Why doesn't the apprentice taking all the information? What is happening in the brain? So we've had a lot of talk about complicated and simple things today. Some of you might have seen Adrian Cockcroft's talk this morning, where he's talking about complicated things and how they're working simple. And some of you may have seen Indu's talk from right before about complicated questions with very simple answers. And to understand how the brain works, here's a picture that shows exactly why I needed a PhD to fall back on in my artistic career. This is a nose. I don't know why you're laughing. This is the brain seen from above. This is what defined in the SOAR model, the cognitive model of the brain, was called the long-term memory, and this is the working memory. And the interesting thing is that in this working memory, in 1956, George Miller said that this working memory can hold 7 plus minus 2 pieces of information. So that's a piece of information you can contain in your head. Chase and Erickson later did a study that showed that if you really work with your cognitive ability, you can triple this number. So you could have 21 different pieces of information in your head at the same time. Unfortunately, the latest research shows that the number has gone down to 4. Present company excluded, of course, but it is the reason why I have only 4 little pieces of information here in the working memory. So what's happening when you take in information? You see things, you hear things, you touch things, and for every concept that you have to work with in your brain, you use one of those 4 holes in your working memory. So these become activated when you take in things from the outside. And you're trying to make sense with what you see and what you hear. Now, of course, you can relate to your long-term memory. You can find things in your long-term memory, and you can decode them and use them in the working memory. So all the experience that you have in your long-term memory, you can take them out and decode them and use them as one piece of information in your working memory, and then you integrate what's happening in the working memory with what you already have. And then this chunking process, this process of taking things that go together and make sense of them into one chunk, then you put them back into your head and you encode these things in your long-term memory. So instead of just having something very complicated that fills up all your working memory, you make one pointer in your long-term memory so that you can pull out a whole complicated net of things just with one pointer. And you've seen this before. So if I say that what you have in your brain now is references to patterns, it probably rings a bell with design patterns, actually things that I spent 4 years of my life on, software patterns, and why they're interesting for people, why you can actually save experience and give that experience to other people in patterns. Because if you have one pointer to a very complicated structure, you can use this one pointer as one of the 4 pieces in the working memory and discuss and work and think about very complex structures in a higher level of abstraction. So for instance, when you're learning about the visitor design pattern, how many of you have learned about the visitor design pattern? Yay. Nobody would say they hadn't. It is very difficult to understand how the visitor design pattern works in one go. You sort of have to understand the element structure and the visitor structure, and then you understand the visit method and the accept method, and you have to chunk it all the time to put it into your long-term memory. You probably remember that when you learned about the visitor pattern, that you had to sort of chunk it and then save that and then learn a bit more. It's not something that you just look at and learn. It's not like the strategy design pattern, for instance, which is pretty easy or whatever you have. So what happens then is that once you understood it, it's now a complicated structure in your long-term memory, and you can pick it out and use it as one little element in your working memory. So now you can work with the visitor and 3 other things, and these 3 other things could be extremely abstract. And why is this interesting to you? Well, think about in your workplace, you probably have patterns in your workplace. When I worked with design patterns, sometimes people would come up to me and say, these design patterns, I don't believe in them, they're rubbish. They're too easy to understand, or they're too complicated. People would sort of be in 2 different areas. Either they would be very experienced in OO, and they would say, there's nothing new in design patterns, I don't need them, it's ridiculous. Which is great, because if you don't need them, then it's definitely a pattern in OO, so it's good to have them. Or people would be novices and say, oh, they're so great, I want to use them all the time. And then they would use singleton 50 times in their system. That would be bad. But actually, you probably have patterns that you don't think about. A very good friend of mine works at Google, and I asked, so are you using any patterns? No, we don't really. I mean, of course, we use visitor all the time, but apart from that, we don't have any patterns. We don't really think about that. And I said, are you sure? Think again. Is there something that you always do and that you talk about? Well, actually, he said, we got something like, if we think we have a bottleneck that makes things slow in our program, and we want to optimize all the time since we're Google. So what we started doing, instead of saying, well, this might be a bottleneck, we want to solve this problem, we want to make this faster. What we do instead is that we take that piece of functionality and we run it twice. So if it's fetching something from a database, we do that twice. If it's running an algorithm, we run that algorithm twice. And we actually call it the double bottleneck. So you have a pattern. So the name of the pattern is double bottleneck, and the interesting thing is, instead of possibly wasting a lot of time working on a bottleneck that's not a bottleneck, you do something which is extremely fast and easy, namely doubling it, and then you check how slow is my program now, and if it's immensely slower, then you probably hit the bottleneck. If it doesn't really change anything, that was probably not the bottleneck. So if you think hard enough about it, there will be patterns in your system, in your workplace, that you're actually using to communicate with the other set. And if you could write these patterns down, that you could help the novice, and you can help the apprentice that we talk about in this case. But what if the apprentice still doesn't get it? What if the patterns are not enough? Then I have to take you back to the beginning of the century, where I was out teaching my first course in the industry. So you have to imagine a very young Aino right out of university, filled with the ideal of object-oriented programming and Java. It's right in the beginning of the Java days. And I was sent out to teach some very old men. They were like 40, 50 years old. I thought at that time they were Asian. And they, of course, didn't think that I knew anything about anything because I was just out of university. And so that was just one of the problems we had. But I ran into another problem. I was giving the same course to all the people in a big company. So I was giving the course maybe 12 times. And there was something that struck me every time, and that's what I'm going to tell you a little bit about. So what I did was I introduced them to object orientation by saying, so we have here a picture of the real world, and then you use object-oriented analysis and design to come up with an object-oriented design. And then based on that object-oriented design in UML, of course. You program this in Java, easy peasy, making beautiful Java object-oriented code. So that's how you should do it. And I was told that these people was very bright. That's why they would spend money on educating them. So I had hoped for them to learn this very fast because it was obvious, right? So I gave them an assignment. I said, here's a picture of the real world. I want you to make a system for this. And what I had in mind was that they would make something beautiful and object-oriented. That is what I expected them to come up with. But what they actually came up with was something as hideous as this. It was procedural programming pressed into objects. And you could see that the objects were sort of breaking. Code were running out of the sides of the objects, and you would have things standing in between the class hierarchies. It was terrible code. It was really ugly. And I just couldn't understand why would it be so difficult for them. And it took me maybe 4 turns of teaching this course before I understood. And I might have been slow. I didn't understand at the time that what happened in their procedural brain was that they had these patterns in their brain that we talked about before that were drilled into their brains. That every time they saw a real-world problem, they would, in a split second, solve this with what they had been trained in. They had the experience that when they saw a pattern looking like this, the automation in their head would take them directly to the answer, which would be functional design or procedural design, and then squeeze it into this Java code. And what I wanted them to do, because that was the way that my brain worked, was that I wanted them to look at the real world in a split second, make an object-oriented model, and put that into beautiful Java code. But that didn't work, because the patterns and the automator in their head was very different than the patterns and automator in my head. Which brings me back to Søren Kierkegaard, a Danish philosopher. And he wrote, at man, når det i sandhed skal lykkes en at føre et menneske hen til et bestemt sted, først og fremmest må passe på at finde ham der, hvor han er, og begynde der. Sorry. I also translated it, that when you want to succeed in bringing a person to a certain place, you must start out by finding out where he is, and then take him there. Because the problem is, if I was just teaching these poor procedural men object orientation, I had to figure out first what was actually inside your head, so that I can break it and start building it again. So what I did instead was that I tried to cut it down in pieces. I tried to change the automation that they had, that they would do unconsciously, by saying, okay, instead of going from the real world to the design to the code, what we do instead is that we break it up in smaller steps. And we say, if we can go from the real world to a domain model, and from the domain model to some use cases, and from use cases to test cases, and from test cases to the design, and so on and so forth. I was trying to break the automation in their head by cutting it down in minor pieces. So if you see some people doing something completely stupid, instead of thinking, as I did, that they must be stupid, maybe start thinking about what is in their brain that they're struggling with. What are the patterns in their head that they're trying to fit into this problem that does not fit? So you have to go back to the Danish philosopher Søren Kierkegaard, who was a great guy, and you could probably learn a lot from. How many of you already knew Søren Kierkegaard? Great, so at least one Danish person. Oh yeah, of course, you lived in Sweden. Now, what if the apprentice still doesn't get it? What if it doesn't help to figure out what's in the brain of the apprentice, and doesn't help to figure out how to chunk the information in nice bite-sized pieces? Well, then we have another thing we could talk about. Because we have these learning preferences, and there's a lot of research gone into learning preferences. This is the Felder-Silverman model from 1988. And I'm sure there are other models, but this is the one that I use when I'm teaching because it fits so well to me. And what he's saying is that we have global and sequential learners. And it is, of course, a line from global to sequential learner, so you can also be in the middle and be a little bit of both. But the difference between a global and a sequential learner is that a global learner likes to see the big picture and can actually, with very little detailed information, suddenly understand a lot of very abstract things on a very high level. On the other hand, if this global preference person or apprentice gets a lot of small details, it will confuse them, and it'll take a lot of time until they get the big picture, and only when they get the big picture, they will be able to take all the details and put them in the right places in their head. On the other hand, if you're a sequential learner, what you need is the small details. Because if you start giving them the big picture, then they wouldn't know how to look at this big picture. They need the details. They need the little code snippets in able to understand it. I saw that when I started teaching, that some people needed a UML diagram, and then they would get it like this, and other people couldn't do anything with a UML diagram. They needed to look at the code. Otherwise, it wouldn't make sense to them. I'm an extremely global learner, so when I started teaching, I didn't know anything about this theory. I just thought that everybody would learn the way that I learned. So I would always draw the big picture because that's what helped me. And then I would have a lot of people being very frustrated in my course, being very bored, saying, oh, don't we ever get to anything interesting, really? And I was getting pissed with that because, and my husband was actually one of them, because I didn't understand why they did not appreciate that I'd gone to so much trouble to try to take the whole curriculum and make a global picture for them. So only 10 years later, I would understand why it was that they needed something different. So when I'm teaching somebody, I'm trying to give the global picture plus some details along the way. Another line is the active versus the reflective learners. There's a lot of lines, but this is the only second one I'll take. The active learner needs to discuss, needs to have activities, needs to work with it, and the reflective learner needs to think about it on their own. And that is why presentations like this does not work at all. It's actually a waste of time for me to talk to you. I mean, it's actually a waste of time for you to listen to me talk to you. It's not a waste of time for me, of course. Sorry, that was disrespectful. What I really wanted to say was that if you prefer an active way of learning, just listening to somebody doesn't work for you. Because you need to say something, you need to discuss, you need to do something practical, you need to solve problems, you need to apply this knowledge. So it doesn't work if somebody's just talking to you or on you. On the other hand, if you're a reflexive learner, you need time to process this. And if I just keep talking all the time, you don't have time to process this. Which is why lectures at universities don't work, which is why I don't work there anymore. Because it's really irritating that they won't listen to me and just drop the lectures, and they don't do that. Right, so I think that it's interesting when you are communicating to people, trying to teach them something, to think about the different learning preferences, to try to understand what's in their head, how you can chunk the information, and what kind of communication do they need in order to actually understand this. So maybe you can support them with some groups, some pair programming. Maybe you can support them by giving them some breaks. Just let them sit on their own. Maybe they need that. But back to the activity. Write as many words from the list that you remember on paper or your phone. You'll get a few minutes to do this. right? So count how many you've got right. You all have a number now? Now I'd like to try this out to see. So how many did you remember? Put your hand in the air if you remembered at least one word. Wow. Right, so keep the hand up there. If you remembered at least 2 words, keep your hand up there. If you remembered at least 3 words, if you remembered at least 4 words. Right, now look around. What do you see? What's the difference between this side and this side? You can take your hands down now. What's the difference? You're better at remembering, right? Yeah. Now let's hear the explanation from this side of the room. What's the difference? Yes. So the main problem for the people over here is that they had no association in the brain. They just counted the number of letters in the word, whilst these people had the chance to look into their long-term memory to find something that resembles this word, which makes it easier to remember. And I'll come back to the theory behind that a little bit later. Because what if the apprentice still doesn't get it? Get a new apprentice, yeah. Or maybe a new teacher. But this is the reality, right? You try and you try and you try and they just still don't get it. And in the old days, you'd just say people were stupid, but maybe they're just thinking in a different way than you. But let's look at the association game that we just tried out. So this is another brain. I won't show you where the nose is because you know that now. This is brain with a content. So you have to imagine that the patterns in the head are now put together in a big lump, which is the content of the long-term memory, the content of the brain. Now, if you hear something new, these events are being processed in your working memory, and then as we saw before, you will start encoding these new patterns and automations into your long-term memory. And when we started this presentation, it was all very well when that was done. But there is a problem with this. As you might already have noticed, the problem is that the information that we are putting into the brain right now has no relation to the information that's already there. And that means that the encoding fails. You probably all experienced that you've had somebody in front of you and you've explained something to them. And they say, yes, yes, I understand it. Yes, terrific. I get that. Definitely, I can do da-di-da or whatever. And then a week later, it's all gone. It doesn't exist in the brain anymore, and you're very frustrated. And you try it again, and a week later, it's gone. Completely out of their head. And that is because it is actually completely out of their head. Because instead, if you can construct the knowledge, if you can encode something that you can put and glue together with the things that they already have in their head, then you work with something called Constructivism that Piaget did already in the beginning of the 1900s. Well, there are different kinds of Constructivism, but this kind of Constructivism is the solitary Constructivism that is about how do you construct the knowledge in your head. And the interesting thing is that when you're teaching anybody anything, again, you have to figure out what's inside their heads, and then you have to build on that. And that's why real-life examples and stories are so good, because that's something normally that people can relate to. And it makes it easier for them to remember because you glue it up with something that's already there. And that is why the people over here with the association found it easier to remember these words. I won't promise that you can remember them in a week, but at least you could remember them for 20 minutes, which is better than the other half. But knowing the content of the brains of the apprentice and knowing how to chunk the information is actually not enough. Because the apprentice doesn't want to listen to you, then your then it doesn't really matter what you say and how much you know. So you have to try to make the apprentice listen to you. And now comes something which is a bit off the side of how the brain works with learning, but I put it in because I still think it's very important when it comes to communication. So if you think about your undergrad math, how many of you can read what it says here, the Greek letters? Oh, is there somebody from Greece here? Okay, just who? There, right next to Mes. Logos? Pathos? Wow, give him a hand. So Aristotle has 3 ways of persuasion. You probably know that also. But in short, logos is what are you saying? Do you know what you're talking about? Pathos is how excited are you about this? How much empathy do you have? And ethos is who do they think you are? So, for instance, when you're giving a talk or when you're teaching somebody something, you have to think about, do I know what I'm talking about? You have to think about being passionate, showing empathy to their knowledge. It's okay to be passionate in a negative way. You can be hating what you talk about. As long as you show some emotion, it's okay. And ethos is who do they think you are. You don't have to be somebody important. As long as they think you're somebody important, it's good enough. This is the way we run these conferences. So we might not all agree with Barack Obama's viewpoints, but nobody can disagree that he is a very, very good presenter. He's a very good speaker because he knows what he's talking about, or at least we think he does. He's got pathos, and, well, he's got ethos, apparently, because we think that he's important. But the interesting thing is that, of course, we can't all speak like Barack Obama when we're talking or when we're presenting or when we're communicating. But the good thing is that 2 out of 3 ain't bad. So if you know what you're talking about and you have pathos, it doesn't really matter who you are. So in my case, I know what I'm talking about when I'm talking about learning, and I'm definitely very empathized about it. I'm really passionate about teaching and brains and stuff like that. So it doesn't matter that I haven't written the right book about this. It doesn't matter that I'm not famous in any way, because I can get away with 2 out of 3. And actually, if you know what you're talking about, and people want to listen to you for some reason, then it doesn't really matter that you're not engaged. There are, of course, places where this is not entirely true. I remember I once gave a database course at the university, and I was so little engaged that we were all very bored. Even though when you're giving talks lectures at university, you should have the ethos because you are on stage and you have a longer education. But it was really terrible. I think I should have needed a little bit more pathos than I had. And then actually also, you can get away with not knowing what you're talking about. If people expect something interesting from you and you're very enthusiastic about whatever it is that you don't know anything about. And you probably, how many of you have witnessed this? How many of you have done this? Yeah. You can get away with a lot of things. So just remember, whenever you're talking to somebody, if you're presenting or teaching or communicating, do I know what I'm talking about? Am I passionate enough? Or can I fake to be passionate? You can do that. And then if you, I learned later that I can fake being passionate about databases. And it works, because the more I was faking being passionate about databases, my body sent the signals to me that you really like databases. And in the end, I found the DBMS system very interesting. So you can fake it so much so that you believe it yourself. And also, am I the right person to be talking about this? It might not be you who's mentoring the apprentice. It should be somebody else. I don't know. Think about it. So just to sum up, what did you actually listen to? How can I become an expert by teaching? How can I improve my own learning and the learning of other people? Because when I'm talking about the apprentice, I was actually talking about you, right? I was talking about how you can help yourself chunk the information, get the global picture if you need that, find time to reflect on it, and find constructivism to relate it to what you already have in your head. And then you had the anecdote to entertain a dinner party with. That was the chess thingy that I showed in the beginning, which apparently was not as much fun in Australia as it is in Europe. So thank you for your time.